Oh, hello, everybody. Hello. How's everyone doing? And Sue's here. Yay. I have to step away for 1 minute. I'm going to make Sue a co-host so she can do whatever she needs to do here. But I will be right back. I just need to check in with my daughter. So Sue, you are now the co-host and you can do whatever you need to do. If you want me to make you the full host, I can do that too.
I'm good.
Okay.
Awesome. Hang on, my machine went to sleep again.
Oh,
There we go.
all right. Well, good morning, everyone. Good morning as we continue day 3 of our conference. And I'm pleased to be able to introduce Sue Klemmer, who is our presenter at this session. Sue started teaching in 1979, and she has been teaching high school science, mostly chemistry and physics, at the same school on the mid-coast of Maine since 1990. She has a BA in chemistry from Wesleyan University, and she's been to graduate school 3 times for chemistry and science education. Each time she learned a lot, but found being back in the classroom was more important than finishing her degree. Her special chemistry passions are the role of particulate modeling in developing student concepts and problem solving, the use of history and science in teaching both scientific concepts and science methods. Her newest cool project is developing a cross-curricular task between her honors chem and college prep physics class next year that will focus on concrete. She is also the Northern Division Chair of NEACT, which includes Maine, New Hampshire, and Vermont. She started the online Chem Chats last year to great success and is excited about continuing them this coming year. So I'm going to just turn it over to Sue.
Thank you, Kristen. Yeah, I just got on Tuesday my grant for the equipment, my fancy IR cameras for my concrete project. So I'm hoping next summer to do a presentation on physics and chemistry of concrete. Anyway, today we're going to talk about thoughts on developing problem solving skills. Leave when you want. It's a fairly small group, so you don't necessarily need to be muted when you're not speaking, but you know, if you got dogs and cats or whatever, that's helpful. Interrupt me with questions at any point in time. As Kristen said, I teach in a public high school of about 750 students. My classes have a maximum of 20 in them. We are not very culturally diverse. Maine ranks 50th out of 50 in cultural diversity in the states of the United States, but we are socioeconomically all ends. Our high school is its own district, which is kind of weird. We have multiple sending towns. Our high school pulls from 5 towns. Anyway, all right. I'm not going to do the official polls that I was going to do. I'm just going to move in here. overall of this talk, we're going to talk a little bit about the difference between problem solving and problem memorizing. We're going to talk about what it means to show work. We're going to talk about thinking out loud in various different ways. This talk came about because, as most of you found out, one of the hardest parts about teaching during COVID, I was simultaneously remote, and I was a hybrid teacher where every day I had some of my students remote and some of them in front of me, is that knowing what they were thinking got even harder. It's hard enough to develop problem solving skills, but when I can't see them and they're not talking to me, it's really hard to figure out what problem solving skills they are developing. So it kind of pushed me in directions that I was already going in, and we want to. So take a moment and think to yourself. I'm sorry, I've got my PowerPoint slide is sitting actually in Notability, and it doesn't always page do it the way I want it to do it. Okay, take a moment and think to yourself, what are a couple characteristics of a student that is a really good problem solver versus a student that simply memorizes how to do a plug and chug, what I call a problem memorizer? And what do you see when you see each of those kind of students? Take about 60 seconds and think about that. Comment in the chat. It would be wonderful to have 20 students as compared to 28. When I first started, all my classes were 30 to 36. I can remember walking in my very first year with a chemistry lab where I could not see all of the chemistry groups at the same time in the lab with Bunsen burners going. It was lovely. Yeah, I am blessed with smaller classes.
I don't know.
Okay, I'm going to ask people to just shout out a couple things. Thank you, Pam, for putting something in the comments. I'll start with hers. A problem solver knows what to do when the context changes. What else characterizes a problem solver?
So I think a problem solver is a student that can approach it many different ways. So in other words, if they see a problem that they recognize, they can, even though it's not A plus B equals C and D, they still know what to do with it. Versus a problem memorizer can only do it in one way. Like I'll always say to students, I can ask the same question 4 different ways. If you've only memorized it, you can only answer it the one way. But if you have it memorized and you understand the concept, you can answer 4 different questions.
I found problem solvers to use an organized format. They dissect their problem so they know where they're starting from and where they're going to, using a format that they use and apply to every problem, checking the answer twice, units, siggy figgies. So I agree with the approach in many different ways. It helps build their confidence.
How about one more?
A problem memorizer, if it doesn't fit the norm, they can't do it.
Right.
I do have something to say here, and that's it's even as basic as the problem solver reads the whole problem first.
Yeah.
Whereas a memorizer, like, oh, it's this type of problem, and starts plugging things in, even if that's not what's being asked.
Cynthia, you look like you had something on the tip of your tongue.
Well, I find problem solvers want to learn, and problem memorizers just want to get through it and get a grade.
Okay, awesome. All right, so we know what we're talking about when we talk about these two groups. The first thing I want to talk about is this whole thing about showing work. Some students really resist showing work. Some students do it because you tell them to do it, and not everybody does it because it helps them solve problems. But you do have to start out, I have some explicit norms, and in both my college prep level physics class and my honors level chemistry class, I have a very simple format. If there's an equation involved, you got to write it out. You got to plug in with units. I'm not one of those people that cares whether you manipulate the equation first, like the physics people like to do, or plug in first. I don't care. You got to have an answer with units. It has to be reasonably rounded. How much rounding we do depends upon the kind of course I'm in. And if it's a really complex problem, then you have to label your work. So if you solve for this first, then, that's the mass of this, this is the change in temperature of that or whatever. You got to label your work as you're going through. It's important to make consistent deductions on showing work. And it's important to practice it, to share examples of it, so I can't wait to be back with everybody in front of me so that I can have teams doing things on whiteboards and everybody else looking at one another's whiteboards, because I thought that was a wonderful way of seeing how people show work. It can sometimes help to remind students that the point of showing work is communication, right? The point of showing your work is to explain to somebody else how you got where you're going. And I give them two examples. One is my brother, who's a retired chemical engineer that used to work for a solid waste consulting firm. So somebody would come to him with a problem. The one I used, because we live on the coast, was a small firm that had they changed the rules on how you would clean up paint. You couldn't clean out your sprayer heads in the harbor anymore. That had to be collected. And they were trying to figure out how to manage painting boats, all these different colors. Their final recommendation was that what they finally decided to do, after getting several recommendations from my brother's company, was you can have a boat any color you want as long as it's white. It just wasn't worth them. They found it wasn't financially worth it to change colors. They'll do pinstriping, but they don't do different colors. Anyway, but I said, if he just gave them an answer without giving them the background and the work and so forth, why would they trust his recommendation? And the other one I always give them, of course, is and I never remember the name of it, the Mars satellite. You guys remember that one, where it took off, got all the way to Mars beautifully, and it was getting the last directions for breaking into Mars orbit. But JPL sent it the thrust in one set of units, and NASA read them in another set of units. They applied the wrong amount of thrust, and it headed into outer space and has never been seen from, again, 10 years of research down the drain. So it's a communications issue. But you do have to be like explicit. My physics friend actually has it right on the corner of her board, up there all the time. I often put it on paper after, worksheet and test after test for the first half of the year to remind them. And they know that, like on a open-ended test, if it's a 10-point question, it's a half a point off for this, it's a point off for, they know what the deduction is going to be. Do I have some students that persist all year long and not showing me work and are just happy with the deductions? Yeah, but you get a bunch of them to do that. And that's part of also me seeing, the point of showing work is communication, but for me, it's also, I need to see how they're thinking. And you can't sell it to them that way, because that's a school thing, not a life thing, but it is important. So how do you get there? Hang on, try that. You teach it explicitly as a skill. I also found something last year that I did kind of interesting. When most of my kids or half of my kids are remote, I kept playing back and forth with, okay, we need to practice this kind of problem solving. Do I give them just the answer? Do I give them a worked out answer? Do I give them nothing at all as they're practicing? What do I do? And I kept doing some of each and so forth. So my standard was, I'll give you the answer so you can know whether you're on the right track, and you got to show work to get credit. and you got to post it before we go over it. Well, now I'm also using what are called annotations that I'll talk about to recoup, because sometimes you'll get kids that didn't post it, but they did put some effort into thinking about it after you went over it in class. So how do you give them credit for that? But again, it's important to take some pictures of good and bad examples or create your own fakes. Sometimes it can be really useful to start out with your own fakes of good and bad shown work, because there's no skin in the game. You're not putting anybody up. I mean, I wouldn't put a name up with samples of good and bad shown work. But walking around and seeing whiteboards, it's that they have to comment on, it's very quickly for the students to realize what somebody else's good work shows up. But you just gotta, you can't assume that they know it, even for your good kids. And you can't assume that they all come in with the same expectations. So be explicit. And then I teach them what I call explicit annotations. And here is an example. Some students will put a general comment. They'll write a comment on their problems. This person said, know which unit you are in. They were doing heat of fusion problems, and some were in calories and some were in joules. And she wanted to remind herself to pay attention to which unit she was in so she knew how to solve the problem. This is what I call an annotation. It's the thing that all of us learned how to do basically on our own sometime in the time we were in high school or college. And it was the savior, right? Because you'd get those textbooks that would go from, you can easily see that you can go from here to here, and you then spent a page working out the work to get from one place to another. Those were annotations. They helped us solve problems. Many of your students don't have what it takes to figure out how to do that on their own. They know how to annotate in English because they were taught how to annotate in English and social studies. We don't teach that. So one kind of annotation is a general comment. I said, if you always forget to put your units in or the round, highlight that. This, by the way, was a student that did her work in Notability. You know, she copied in my worksheets and then wrote things out, and so she could easily highlight stuff. And the other one is a more specific kind of annotation. This student had trouble learning how to do dimensional analysis. And so they wrote themselves, the gram degrees C cancel out the grams in the Celsius, even though they're not touching. It was the first time we had seen a dimensional analysis problem which had 3 units instead of 2. And he wanted to remind himself that, okay, I'm going to multiply by the grams and that cancels out the grams. I'm going to multiply by the Celsius, that cancels out the Celsius. And they're not right next to where they were originally, but it still cancels out. So he wrote himself a note. So those are annotations. And I give them examples on how to do that. And then I start requiring on every set of problems that they turn in that there's at least 2 annotations. What's really fascinating to me is that they haven't figured out, nobody's copying those yet. And maybe because it's a new skill, but you know that one student's just copying the work of others in solving the problem. But so far, nobody's copying the annotations. They're writing their own. And it takes you like 5 seconds to look at whether or not they put annotations in. All I look at to see that they've got their work before we go over it is that I see something in front of me and I see annotations. I don't care if it's correct or not. We work on that when we go over things. So it's 0 time. Make your students work harder than you. They've done the annotations and they're personally meaningful to them. The way I use it to recoup credit is I will say to students, okay, if you did not post these problems before we went over them, you can still get credit for these problems, but now you got to annotate all of them as we go over them and turn in your work. And so I know they're at least thinking about, they put some skull sweat into it. And I don't give them back 100%. My problems aren't worth very much to begin with, but I don't give them back 100% just to acknowledge that, yeah, you were supposed to do the problems before and post them before we went over them in class. But it does A, practice the annotation skill, and B, force them to show me that they did some work. Questions, comments about annotations?
So Sue, how do you teach them to annotate?
By examples. So when you're doing a problem on the board,
Mhm.
I'll put in an annotation and tell them, you know, because we'll do a problem and then I'll turn, what I often do is I'll do a problem and then I'll say, turn to your neighbor. What's the hardest part of solving this problem? Or what do you think you're going to forget when you do one of these on your own? And I elicit those comments and I write them on the board. Yes, I still use a blackboard. Although last year it was my iPad. But so you do it yourself, you model it.
Mhm.
And the first couple times that they're doing it in homework, now that they're going to be all in front of me, I may have them walk around and look at one another's annotations. You know, go look at 3 other people's annotations. Because one of the things I want all of my students to do during high school is to experiment with different ways of doing things, different ways of studying, different ways of annotating. You know, you got to, and they hate to do that because like they find one that works and then they could be, students can be really hesitant to change. But I said, you know, try something, and because you won't know if it doesn't work until you try something. I give them the example of my roommate freshman year, who her way of studying for a test was she had a second notebook for every course. And beginning a couple nights before the test, she would rewrite all her notes from one notebook to the other one. And I said, I tried it once and it made me bang my head against the desk. It didn't help me at all. But she did really well. It was her way of playing a video of the class in her head, and it worked for her. So, you know, I said, try something that's different. And that's true for annotations. And I find, particularly because mine is usually the first course where anybody's ever looked at their annotations before in a math or science format, that they do evolve during the year. Some students will switch from specific problems to overall, and some switch the other way. Some do it, you know, flip back and forth. Some kids quickly find, particularly if they're using something like Notability, that their highlighter is their best friend. You know, there are many ways that they find to do it. But I do think that it helps them. My assessments, my unit tests are partly closed book conceptual and partly open book problem solving. And I do think that having those annotations after, particularly if you help out a couple of kids, they do poorly on a test and you get them in for some extra help. And you say, well, show me the problem that you were using to help you solve this. And oftentimes, particularly at the beginning of the year, they're showing me something that just has the problem solved. There's no notes. And I said, well, how was this useful? How did you know that you were supposed to put times 80 grams there? Because that was something they didn't do in the real problem. And then I said, so that's what you have to write for your annotation. Remember to, you know, circle the mass in the problem and this is where it's going to go, or whatever. Every kid finds their own way to annotate problems. And in fact, some kids do find that, because somebody was talking about that good problem solvers really deconstruct and organize the problem. And for some kids, that's what their annotation is. They're listing the things from the problem, or they're highlighting or circling them or whatever. Again, kids do it different ways.
Do you use an organized format in the beginning for problem solving, like find, given, need, solve?
The one I use is just the one I said, which is if it's got an equation, write the equation, plug in, and so forth. But I do not use an overall, you know, a lot of people will say you got to write down what you need and you got to write down what you know. I do go through some different formats for different types of problems. You know, dimensional analysis, the first time we get something that's got a wicked amount of data, like specific heat of a metal where you got the water in the metal and so forth. And I say, you know, you may have been quite fine just finding the data up until now, but this is a problem with a lot of data. So think about, maybe you want a table. So I try not to give them one format, but I do try to encourage them to have a format. And if I'm working with a kid one-on-one for extra help, I will often say to them, what's your format? And make them, I'm going to talk about thinking out loud, and I'm going to make them say out loud how they're solving the problem and kind of work out what their format is and help them organize it.
I can understand that. Unfortunately, in our school, they took the collaborative classes away. And they've put those students with needs in general pop. So, you know, for most of the assignments, I do give them models. I do model how to attack the problem for using dimensional analyses. And that's one of my expectations at the beginning of the year, that they have to use the steps because it's an organized, that's the whole thing, is kids with ADHD or ADD or have processing issues in going in or coming out, they need that extra form of education, that organization. And within that, later on in the year, they can kind of phase out. So,
Yeah. That's fine. I do what works. Good to, you know, Sham Shakashiri was talking about good teachers, and good teachers all have their own way of doing things, and there's not one way. I'm going to keep moving because I have limited time today. Productive science talk is something that was worked on by the University of Maine, and I included in the, if you go to today's printouts, you've got my printout for this. This is a series of prompts that are organized by what kind of talk you want to do. For example, one of them is our clarifying, you know, like clarify the issue, and it will say, tell me more about, what did you mean when you said? And it's literally prompts for kids to talk to one another about problem solving. And I give them a laminated copy of this at the beginning of the year. We don't do all of them. There's like 10 or 12 of them at once. We start at the beginning, and I'll say, in your discussion today, would you please use one of these two prompts or something like that? And at first they think it's pretty hokey. And then when they realize they've used it a couple times, and then I say, you know what? These same prompts works if you're having a meeting with your soccer team and you're trying to decide something, or you're on the prom committee and you need to make a decision, because it's the same kind of, you know, productive argumentation skills that are good for everything. And they generally come around to using it. But it is, again, something where students need to be taught how to talk to one another about science. You know, you got to start with things like, yeah, you talk about their ideas and not the person. But it helps to actually explicitly work at those skills, to keep at it. I will sometimes ask at the end of a day when we're doing particularly group work in which I've asked them to focus on a particular area of productive science talk, that might be my exit slip for the day. How did you do on talking and listening today? What worked, what didn't work? So that they know that I'm paying attention to it. Because of course, they're all good at doing school. If the teacher isn't going to pay attention to something, then they're not going to pay attention to something. So they need to know that I care about their talk skills. And if I'm walking around working with groups, I might be listening for that on a particular day when I don't think the task is particular, you know, the content might not be particularly challenging. So maybe I'm paying attention more to the group dynamics. And I'll say, gee, Kristen, you know, that was a great that was a really great way to disagree with Pam's idea, or whatever, you know, or I'll use the talk moves myself to kind of model it. So I think that teaching kids how to think out loud and talk to one another is a part of problem solving. It's the collaborative part of problem solving. And particularly, it's not as hard, interestingly enough, in my CP classes, but my honors classes where the kids want to do it themselves and not collaborate. because, oh, so-and-so is going to bring my grade down. I'd rather just do it myself. It's really important to teach these skills and show them that they gain. The group does better if they actually learn how to think as a group. POGIL. Is anybody here not familiar with POGIL? Well, you can use things from POGIL without writing a POGIL. One of the things that I really like is the little stop signs in POGIL exercises, which is where the group has to stop and check in. One of my problems when I'm doing group work is that I get buried in one group and I'm not necessarily paying attention to all my groups. So if I put stop points in, it takes the burden off me and puts it on the groups to check in. And so I know that I've checked in with everybody several times during the period. It's a way of checking in on everybody's problem solving. And I'll usually put it in someplace where they've either just finished something that they really had to do a lot of talking about, or they're just about to begin something where they really should be doing some problem solving and not memorizing, that's really kind of a push. Listen to that. But I think it builds, again, the management skills in POGIL are one of the reasons why its problem solving can be so successful. And good group management leads to good group problem solving, and that can then lead to good individual problem solving. I also like the idea of when you have a group, telling them that everybody's got to submit the work, but you're randomly going to pick one person and grade theirs, because then they actually talk to one another about how they solved it and argue about why their answer is correct. And they're, again, talking about their problem solving, sharing how they're thinking with other people. And I just think that thinking out loud and sharing how you're thinking is how you develop problem skills. You don't develop them on your own, sitting on your bed with music in your ears, isolated from the world. You develop some problem skills that way, but you don't really develop good problem solving skills in science unless you're being challenged by other people.
You're suggesting doing that this winter during one of the chem chats saved me during hybrid, asynchronous, synchronous garbage this winter, because that was the only way I could get kids to actually work together in breakout rooms.
Yeah.
So thank you.
You're welcome. The American Modeling Teachers Association does a lot with whiteboard meetings, board meetings in which groups are putting their stuff on these huge whiteboards, and then they're coming up to the front, or all the groups are standing around in a circle and they're presenting their work. I think that, again, it's thinking out loud. One of the things that we came to in one of the workshops I went to was a teacher that if you've got multiple groups solving the same problem, everybody props up their boards or stands with their boards, however it works in your room. And the first thing you ask is for people to say, what do you see? Not like, my answer is different than Judy's, but what do you see? Not interpreting, but what do you actually see on the boards? And then you pick a presenter so kids can't hide because they don't know who you're going to pick. And of course, I'm going to pick the person that's talked the least lately. And I'll pick several people to talk about things. It makes more kids explain the thinking that's going on. Now, I occasionally have had groups that are so afraid of failure that they totally freeze up at trying to talk like that. I mean, I've had groups that really, really, really are terrified of talking. And I found that they were very, very comfortable doing a gallery walk around whiteboards and leaving sticky note comments. They would write comments that were quite insightful that they wouldn't speak. And then I would speak their comments, or the board that got the comments would speak the comments. And it broke the ice, and you can then move into, and when they heard several times their words, somebody else speaking their words is very powerful. To hear your own words being spoken by somebody else, it's very empowering. After a while, then they would get to the point where they'd be willing to speak their own words. So using sticky notes or writing comments before they speak comments, it's really funny, but I've got some, A-type perfectionist kids who are just, they've identified themselves that they're not the brightest kid in the class. They do all right, but they're not the brightest kids, so they're not going to talk because it's not going to be as good as, and it's a shame, but I'm dealing with what's already been embedded in their brains. So those kinds of things that I'm stealing from AMTA, I think are wicked awesome at getting kids to share. And the questions that you're asking when they're presenting are, again, like, why did you do that next? Or where did you go first? Or what did you pick out from? So if you've got and particularly if you have an expectation of a particular kind of problem solving and you're not seeing it on a whiteboard, get them to walk through how they did it, or pick another group that did that and have them model, well, we did this for, we found our needs and then we identified what we had, blah, blah, blah. You can do it either way. You can either walk from the kids that, and of course, personally, I love finding the group that solved it a completely different way that I hadn't even thought of, and going, you got to tell me how you solved this, because this is really cool. And when I'm enthusiastic about a way that I don't understand how they solved the problem, and I show that I'm really enthusiastic about it, that really validates their own problem solving. I don't have to be a Clemmer clone. I can think for myself. I had a student last year who solved many mathematical problems in words because he's solving them in his head. And he goes, so first I realized that this was twice, that the blah, blah, blah was twice the blah, blah, blah. So I multiplied by 2. And I got him to finally, I said, you don't have to write me the dimensional analysis if you can write it in words. He's not going to become a physics or chemistry major. He was a musician, for goodness sake. All right. He's already getting almost as much money as I make with a band, with a professional band. He was the only kid in this adult band, Why should I make him solve it that way? And whenever I got him to talk about his problem solving, the other kids went like, oh yeah, I get, like some of them will go, wouldn't understand the way I solved it. They'd understand the way he solved it. So again, the more you can get kids to share the way they solve problems, it improves their problem solving and it improves everybody else's problem solving. But again, sometimes you can't get kids to talk. So sticky notes or Padlets or Jamboards or whatever you're using as a way for kids to post what they're thinking. I'm going to go on to one more, and then I'm going to stop for lots of questions and comments. I realize I'm racing. This is one that if you listen to Chem Chats this fall, you heard about, because I'm really excited about this. There was a professor from BU, I think, who had the awful problem this year of having some kids in person, some remote who were synchronous because they were living locally, and a whole group from China who were asynchronous because they were 12 hours off. And she's trying to get accountability for problem sets for chem, the standard intro chem test with problem sets, and how the heck do you know whether a student actually did it themselves? And we agreed there was no way to really know it, but what she had the kids do was to record their own voice solving the problem. And I took this idea and I simplified it so that some of my formative quizzes are, I give them a problem to solve. And usually I've got maybe 4 problems for a class of 20 or 24. And they write out the problem and then they record their explanation of how they solved the problem. And we do this in Notability because we happen to be an iPad school. Every kid's got an iPad. And Notability has a really easy to use function for that. They already know Notability. It's a no-brainer. It's amazing how little time it takes. You actually don't have to listen to the whole recording for most kids. And their recordings are maybe 2 minutes long. But sometimes I'm listening to 30 seconds of it. And I'm going like, yep, I'm seeing that the problem is correctly solved. And I'm listening to them. A lot of them are really nice because as they're recording, they're highlighting the parts of the problem. Again, I give them a sample at the beginning of the year. And then I give them, we practice. So we take a set of problems that we've just finished that I know everybody has how to solve the problem. And I say, submit this one with an audio recording so that I know that everybody can do the technology. And then I use it I ended up just using it for low stakes quizzes, but I don't see why you couldn't use this for a test question, depending upon your circumstances. But man, you really find out who gets what they're doing, and you really hear it's, for the kids that get it right, it's fast, just as it is if you're grading any other kind of problem solving where a kid knows what he's doing. But for the kids that don't know what they're doing, I found that it saved me a lot of time when I went back and helped them out, because they've really told me what they don't get out loud. And while I sometimes don't understand from what they write on paper, boy, out loud, I can find it out. So maybe, once every month, they're doing one of those. And I pick which kinds of problems. It should be something that does not take them a long time to do. That's their buy-in. And they have told me in course feedback that most of them are very skeptical, like, what crazy thing is she asking us to do now? But then they realize that, yeah, you know how she used to tell us to do your studying in front of your dog and talk out loud to your dog? It's kind of like that, and it works. So most of them do come around. You never get everybody for any technique that you use. Yeah, Kami has voice annotations. Flipgrid is another good one. Whatever platform you use for this is totally up to you. I did have one person who ended up writing her script out because she had laryngitis for 2 weeks. And she wrote me and said, Ms. Clemmer, I literally can't talk. And it was funny. She was one of my most perfectionist nervous Nellies. And I said, just write out your script for me, It worked. So, don't get too hung up on the method. Be kind to yourself. One of the best things I ever heard from any of the graduate professors I ever had was, you're not responsible for teaching them everything. You're responsible for pushing their thinking forward and then handing them off to the next person who's going to continue mentoring them and helping them develop. So problem solving is a continuum with lots of bumps, roller coaster ups and downs. None of us proceed linearly in problem solving. When we're tired and when we're stressed, we go back to memorizing. We all do that. And it's okay. It's a part of what being a human being is. And we've all, last year, talk about low energy and lack of time, there it was. It takes many years to develop good problem solvers. So pass the torch. And I wanted to leave 15 minutes for questions and comments and all your other cool ideas. And I think I just did that. One other thing I want to share while you're thinking about your questions is I would like to just show you what I put in. What did I put in the folder for today? Why is it that Zoom always covers up all of my menu for my everything else? It's like no matter where Zoom puts its bar, it's always where I want to go on my desktop. I don't know why it does that, but it's really good at that. All right, NEACT. If you go to the Google Drive folders and you go to Wednesday presentations, you will find the productive science talk norms, which is both some general norms for a classroom in which productive talk is happening, and then all those actual productive talk things. You will find my self-reflection on showing work. One of the things I do at the end of each unit is I ask kids to do some metacognition, some self-reflection, and I give them a choice of things. So some are usually content-based, you know, how did you meet this particular unit objective of, you know, learning how to do dimensional analysis or learning how to do nomenclature. But some of them are also general, like showing work, independent work, prepping for tests, writing CERs. And there's a little form where they sort of check off, it lists, this is what it looks like. And then there are places to check off, these are the things I've got, and a place to check off, these are things I haven't got, these are my next steps. And I encourage kids to come back to some of the same ones over and over. So I've included the one for showing work on problems that a kid might do once and say, you know, I've nailed this, or they might do 4 or 5 times during the year. So I have maybe 10, 12 units during the year, so that they'd be doing this that many times. And I think, oh, and I did put in, POGLs are, you know, you pay for those, but I modified one and I stuck it in here just in case there were people that didn't know what POGLs were and didn't know what the heck they were talking about. And I just remind you that that is proprietary to the POGL dudes. Although I did think that that was a worthwhile purchase to buy their POGL book. And once I've used a bunch of those, it's worth the time to modify things, or to simply take an ordinary worksheet and stick in a couple of stop places. Or the other thing that they use is a takeaway, and they literally write out what the takeaway is for something. Anyway, I'm going to stop talking and listen to questions and your brilliant ideas.
I just wondered how, at the beginning of the year, you help students get over that hindrance to explaining their thoughts, where if I ask them like, oh, how did you get that? They assume that they're wrong. And so they just get really panicky. And so I have to be like, no, that this doesn't mean you're incorrect. I want to hear your thinking in that. So I tell them that immediately and I remind them that, but there's still students at the end of the year who still feel that way. So I just wondered if you have.
I don't get that. It really depends upon the kid. For example, the other thing I do is on all my demos, they've got to predict what they think is going to happen, and they've got to come up with a particle explanation. And there are certain kids that no matter how many times I tell you, I'm not looking for the scientifically correct representation, I'm looking for anything that just matches the evidence, be creative. They're still looking to their friends to find, you know, what's the right answer? What's the right answer? And if I have a kid who's really anxious, I will actually make a bargain with them. I'll say, you got to find like one time, tomorrow we're going to go over these problems. You got to find one time that you're going to raise your hand. And I promise I will call on you then, so that they're comfortable about contributing. And you can't do that. And particularly, like I had one class 2 years ago that had like 5 kids that had 504s because of anxiety all in the same class. And so, you know, sometimes that's not doable, but sometimes you can, you can make bargains. Or the other thing that I do that sometimes helps is I will do what's called turn and talk, which is you've just talked about how to do a problem, or you just gone over something, and you pause and you say, turn and talk to your neighbor about something you learned, or turn and talk to your neighbor about something that still isn't clear, or whatever. And then what I ask is for you, I'll call on people and say, what did your partner say? Because they're willing to share what somebody else was thinking, not what they were thinking. And sometimes that will break the ice. What did you hear from your partner? First of all, it's a good way to break up things. The person that taught me that said that you should never talk for more than 10 minutes at a time without pausing, which was a shocker to me. And I'd been teaching 20 years at the time. It's like, really? And he says, yeah, I work with, he does nonverbal communication with all kinds of people. And like, yeah, and he's right. So walk and talk or turn and talk. The other one is if your kids are really, particularly at the beginning of the year when they're not used to sitting, instead of turn and talk, tell everybody to stand up and start milling around the room. And you call out stop, and then they find somebody next to them. And again, you've got a prompt like, tell me one thing you heard in the last 10 minutes, or tell you one thing that you think was interesting, or one thing that was confusing, or whatever. Anyway, that may help. Other ideas from others? How do you get the scared ones to talk?
I think for me, anytime I try to have those scared ones talking, I think it all starts at the beginning of the year, and just getting them comfortable talking about even just like interests or like previous knowledge, and getting them so comfortable in your classroom and that it's okay to be wrong, and setting up that environment. Especially like in my AP, setting that at the beginning, that this is a hard course and not everyone's going to excel at it. And so when I ask you a question and you don't know, or you're worried that you're wrong, it's okay, because you're not the only one. And that's why we're here working on what we're working on.
Yeah, I have one friend that uses 2 truths and a lie. She starts her class where every kid writes down 2 true things and 1 false thing about themselves. And then the rest of the class is trying to pick out which one's the lie. So you're deliberately being false, and she finds it's an icebreaker to get kids that don't. She teaches a lot of freshmen that come from different schools and don't know one another. And it's interesting, for some kids, it's worse if they've been, they're with the same kids every class, and they've sort of gotten themselves pigeonholed into the, I'm the person that doesn't talk, and everybody has enabled them to do that. Other questions, comments?
Sue,
Yeah.
I start the year off with a icebreaker, where applying multiple intelligences, they have a sheet which has pictures on it, and they have to go around and find the one who, has done what that picture, is depicting over the summer, which gets them running around and learning about each other. And it's really a great little activity, and you can keep doing that, at the end of a unit, or,
I like it.
it's a great way to do it. And they love it too.
We did selfie Kahoots this past year, was something I learned from the Kahoot people, where you make a 4 or 5 question quiz about yourself. And so that was an assignment I gave everybody, and we started every class for the first month or so with somebody's selfie Kahoot. And sort of celebrated, who knows the most about, Kate, who knows the most about Anne Marie? And because that was how I was trying to deal with remote, but I might do that again this year, even though we're in person.
I did that same idea with a 2 truths and a lie. Like, they made it, but that's how I started class for a bit, because we were remote the first 2 weeks. I adapted because you talked about the selfie Kahoot at the conference last summer, but they really liked that. And then I did it on Pear Deck. So you got like the multiple choice, so you could see that. And like, I didn't know the answers, so I didn't log in, but I was still like, oh, that's not what I would have picked. So that was a cool way.
You could do them.
Do a Kahoot, but
Thinking off the top of my head, why couldn't you do that with content? You tell them you're going to say 2 truths and a lie about yesterday's lesson, last lesson. And maybe you'll get some of the, again, yeah, any way that you can get and I also find that a lot of those scaredy cats do better in small groups. And so if you're walking around and sitting in on the small groups, praise them every time you hear them speak. You know, really show, and don't do it so obviously that then they get embarrassed, but, you know, like really show that, wow, I'm really interested in what you just had to say. That was a great contribution. And by body language and so forth, you can, and occasionally, if I have a student that I know really well, like I had them in a previous class and they're really, they're one of my nurturers, I may ask them, I'm saying, you know, you're going to be in a group, because I keep my groups for about 2 or 3 weeks and then I rearrange them. And I'll say, can you be Kristen's buddy? You know, I just need somebody to make her more comfortable in class. And it's not often that I have that opportunity, but if I do, I grab it. It is a problem in our society. You know, certain kids don't get valued.
Not only that, you're helping them to understand individuals' differences. I did that with a child who was Asperger's, high functioning, had some social skills, wonderful child, struggled with eye contact. And I would pick one student at a time. Well, would you be this child's lab partner, which is a study buddy? And, you know, we talked about it and they were great about it, because we have they have something where they pair students off with children with disabilities, cognitive impairment, whatever it is. They are a part of this program, and you know, it's part of the program, and they just love it. They're very accepting of everything.
One year I was teaching a tech prep course and I had a whole group of kids that, oh my God, any one of their home life situations would have buried me. But they were really interesting because they were completely supportive of one another. So, you know, somebody would come in and say, you know, so-and-so's got their emancipation hearing this afternoon. They're really kind of nervous about it. And the one thing that was funny about that class is I ended up not giving them tests, because the one thing they could not do was to sit there and watch the person next to them struggle with a question. They had to turn around and help.
Wow.
And I quickly came to the conclusion, it's like, geez, what's more important for their life, that that they're good neighbors, or they quote know how to do a test. So we found other ways to do assessment, because they could not do their own test without turning around and helping one of them. So they taught me more about being a human being, I think, than any other class I've ever had. An extraordinary group of young folks.
I had one student, she was amazing. She had a lot on her plate, home life, very angry, through most of her, time in school. And we were doing a very structured dimensional analyses. I call using tracks. They look like railroad tracks. We started with math builders or STEM builders, and then kind of phased off. And this girl jumped up in the middle of a lesson, very excitedly saying, I got it. Can I show the kids? I said, go for it. And she explained the whole problem. And then she turned around, can I go help other students? Works for me. And that was the first time in her entire time being in school, that quarter, she got an A. She made the connection. And it's like, wow, brought tears to my eyes. She thought she wasn't smart. And then she realized she was, and shared it with everybody.
I'm going to recommend a podcast/book to people. I don't know if anybody listens to Hidden Brain.
Oh yeah, I love it.
I love it. I catch it on NPR. Well, they had one about a week ago by the author of a book called Choke, CHOKE. And what they were doing was connecting things like an athlete choking at a championship game and unable to perform, to a kid with math anxiety who freezes on a test, to somebody who can't speak in front of the class. And they talked not only about what's going on in the brain when this happens, but how do you deal with it? I'm actually hoping to make that a book group at school this year, because we do a lot of teacher-driven professional development, because I think it'll bring together the math science people and the coaches and the wellness, folks and so forth. But they really talk about the fact that we actually have the same physiological reactions to excitement that we do to anxiety. Rapid heartbeat, all this kind of stuff. And that there are ways to train yourself to interpret, and I've certainly seen my my drama kids do this. How do you interpret stress stuff as excitement and use it as a positive? It's really cool. It's really cool. But it's such a human book, but I think it's perfect for educators on helping all of these kids that are afraid to talk or afraid to problem solve, afraid to share their own thoughts. I'm afraid to be wrong. I think it's all related. I think it's all related to stuff. And so this book called Choke is getting me to think about it. But I'm sure you can find The Hidden Brain. If you want the short version, listen to The Hidden Brain on it first.
The recent experience with Simone Biles is exactly an example of choke. I mean,
Yes.
there's someone who is
Yes.
top in her class and then all of a sudden just couldn't.
Yep. It is 12:01, and I do not want to keep people beyond their lunch break since we have all this cool stuff that we're going to be listening to this afternoon. And in fact, I got to run. I'm going to leave this session open in case some of you just want to chat with one another. I have put my email in the chat in case you have questions specific to me. And I'm also going to make another plug for Chem Chats. The first one is coming up the 9th of September, and there will be information on the neact.org website after this conference is over. It'll show up as the next event if you want to join us for that.
And I posted in the chat the links for the afternoon session. So if you're going to the collisions chemistry session, and if you haven't used those games, they're really worth checking out. They're really cool. And they are going to be, I believe they are still no cost for this coming year, but I can't speak for after that. If you're coming to my Desmos activity, if you want to start writing your own Desmos activities, it's got a separate link. So you'll pick accordingly. I think they're both going to be really good. You're not going to go wrong either way. And yeah, it's definitely time for lunch. And I know I need a movement break. And I will see you guys all at 1:15 or not.
Thanks,
depending
Darley.
on what you're doing.
Thanks, Kristen. I am coming to Desmos because I now have some capacity to learn a new thing.
Right. Well, it's going to be literally like, right. So if you're coming to Desmos, I'm just going to say that if you're coming to that, bring a problem set or a question set, or open up, I don't know if you use like problematic or Regents chemistry questions, bring questions with you, because we're literally going to write the Desmos activities and then write in the script so that they are self-checking. So the more for that to be the most productive, you really want to have some questions to work with.
All right.
Thanks for telling me that. But again, Sue, thank you very much.
Yeah.
Oh, you're
this is
welcome,
really
Judy.
good. All right. I can
Thanks,
leave this
Sue.
open if people want.
Thank you.
I think we're good to go.